Hey guys, I'm gonna make a couple general announcements here, and some of these are kind of selfish of me, but that's okay because you're in my space. Um, we have students who at this point are like getting comfortable, which is good, but they're taking their comfortability and making that turn into like, what can I get away with? And that's really not a good idea. So I'm going to make this announcement now as opposed to trying to deal with it like partway through class, especially because I'm letting you sit wherever you want this week. This is kind of like a test of your maturity. And really, like every moment, if we're trying to be honest here, is a test of your maturity. If you walk into a classroom, probably not appropriate to just be like whistling and carrying on and making as much noise as possible. Like that's not appropriate. Right, so really the trick to life comes down to impulse control. As I caught Mr. Shirk's attention. That's really all it is, right? I want to go ride my bike, but I need to do my homework. I want to talk across the room at Jessica, but I need to write down my notes.
Can I give my 4-bucket?
Yeah.
Yeah.
I don't know what you're talking about, but
My
sure.
4-bucket philosophy.
I don't know what that is.
So I have a daughter who's in 6th grade, and we talk a lot about your 4 buckets and her 4 buckets, and we get into fights about her 4 buckets all the time.
This is what I love about not having a door. Anybody can just come in whenever they want.
So you have 4 buckets. Things you want to do. Things you need to do. Things you don't want to do. But need to do them. And then this is the weird one. Things you need to do, or things you don't want to do, and don't need to. So I always start with this one because it's like, this is the toughest one to conceptualize. What's something that you don't want to do and don't need to do?
Does it have to be practical? Because like I don't want to change diapers and I don't need to, so huzzah, I win.
Right. So Hudson changing diapers. I'm just gonna say HUD diapers. Alright?
I don't want to wear diapers either.
Okay, for me, like I think about this and it's like, I don't want to do this and I don't need to do it. And that's go to jail.
Go to what? Go to jail.
Go to jail. Like, I have no desire to go to prison, and I don't need to do that. But that impacts like the choices I make, right? Okay. So really, you're only focused on these 3 buckets. What do you want to do? What do you need to do? What you don't want to do, but you need to do it. Like math homework for some people goes in this bucket right here.
And again, as we talked about yesterday, for this class, it shouldn't really be in that bucket.
I don't care what, like everybody has this. You know what mine is? Mine is full-scale safety drill. It's one of the most important things we're going to do all year at Phoenix, and it's part of my job, and we're doing it next Thursday, October 11th at 2 p.m. Just saying. But I need to do it. We're going to do, like, we'll go to our rally point. It's no big deal. It's all good stuff. All right? So we're going to do that, but it's a lot of planning on my end. I really don't want to do it, but I know if I want to do some of the things I want to do, I got to take care of this. So, like, in your life, you probably have a lot here, you have a lot here, and you have a lot here. But the secret is, and this is what a lot of young people don't get sometimes, if you take care of this and this first, so what you don't want to do but need to do, and the things you need to do, guess what you get to do more of? The things you want to do.
Well, what if I want to do something but also want to procrastinate and do it?
So I'm going to use my daughter as an example, okay? So my daughter loves, okay, she loves to watch TV. Like, she is a movie buff. She wants to watch, like, that's her go-to. Like, on Saturdays, she don't want to do anything else except watch movies, right? But if during the week she didn't turn in her homework, if she didn't do the things that we have as expectations, guess what she's not doing on Saturday? Watching movies. So it is what Mr. Hudson says of impulse control, or you could call it prioritizing. So these are sometimes not fun things, right? But it gets you to do more of what you want to do. Does that make sense? So when I ask you what are the 4 buckets at some point in time, you're going to be able to say those 4 things. Questions. What questions do you have about the 4-bucket theory?
Can I kick any buckets?
You can kick as many buckets as you want, but there may be consequences.
Oh, okay.
You kick the bucket down the road if you don't want to do but need to do, that's going to have natural consequences for you. A lot of these things have natural consequences, positive and negative. What other questions do you have about the theory? All right, 4-bucket theory
I
done.
like it. I
Sorry
think
for
we did
interrupting.
talk about this at one point. I forgot that you call them buckets because that's a T-chart. Well, not really a T-chart. It's a 4-quadrant graph is what it is.
I'm tired of battling semantics with you today.
This morning started with Mr. Sherg talking about frisbee golf and me adamantly saying they're not frisbees, they're discs. And ever since then, one of the reasons I like working at Phoenix is we have a good relationship with each other. So that resource page from yesterday, and my smartboard's being funky today, we should have our data from yesterday's pattern analysis, right? Our tile pattern, our figures, and we yesterday worked through figuring out how many tiles would be in figure 0, how many tiles would be in figure 4, and we should have all this, right? But we may not have this all filled in. So let's real quickly get this filled in. For tile pattern 1, back here, and I should probably just pull up the other resource page, I think. Right, these, what did we say for tile pattern 1 was going to be the number of tiles in figure 0? 2, and then we grew by 4, right? So 6, 10, 14, and then 18. What did we say in pattern 2? 1, 5, 9, 13, 17. Yeah, how many? It's 3 to start. And then does it still go up by 4? 3, 7, 11, 15, 19. And then, yeah, Kitty. Oh, snap. I might have put them away somewhere. I can probably just give you the one from the back of here. I'll print another one later. I should have had extra yesterday. I should have extra somewhere. In my extra paper area. Yeah. Yeah, well, it's like multiple years worth. Because essentially, I just need to do a mass recycling. And then tile pattern 4. How many did we start with? 3. What did we go up by?
2.
All right, so we have that. Going to put it up on the TV. And now we're going to take this graph down here. And we're going to scale this out a little bit because I'm not going to put like figure 0, figure 1, 2, 3, 4. Like we can use more of this graph. Right, so decide how many boxes you want to make to be a figure number worth. And once we do this, we're going to go over homework, by the way. I just wanted to wrap up this little part of this lesson. I know some people had issues on the homework. I got a couple texts last night. I was trying to get some yard work done, so I couldn't really respond to everybody. But we always assume this is 0, 0 point. Unless we have a reason otherwise. In a histogram, that might not be 0, 0 point. Histogram might start the x-axis at a value. But if we say that this, the bottom here, is figure number, then this axis is going to be tiles. So my figure numbers need to go up to 4 and could go higher. So if I make like, I don't know, every 5 boxes, 1, 2, 3, 4, I'll make figure number 1 right here. 2, 3, 4. And then we can predict. We can keep going. For figure 5 and 6. And even potentially 7. Now my tiles right now only go up to 19, but if I'm going to go out to figure 5 and 6 and 7, I should probably go higher than that. So how high do you think we should go for the y-axis? By the way, please jot down an x and a y just to remind us that these are the x and y axes. How high should my tiles go? I don't want to stop at like 19 and just get where I need to. Can I stop at like 20? I don't know, I'm going to go out to figure 5, 6, 7. 30, Connor? 50? 50 might be a little high. I know I'm going up by 4, right? So if I go 3 more, that'll be 12 more. So if I go to like 30-ish. So we can count our boxes, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 boxes. If I go by 2s, it would easily take me to 50. And that might be higher than I need to, but that might be real easy. So, yeah, we can just go by 2s. So, but I'm not going to label every 2. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 4, 6, 8, 40, 42, 4, 6, 8, 50. Then place appropriate points for each of the graphs. For each of the tables. So for my tile pattern 1, I'm going to start at 0, 2. Then I go to 1, 6. 2, 10. You're going to need a straight edge today. Something straight. Edge of your book, whatever. You notice tile pattern 2 is always just 1 below tile pattern 3. Tile pattern 3 You're trying too hard. I would accept your joke if you were with me. Like if you had everything that I had up on the board. Tile pattern 3 always has 2 more than tile pattern 2. So if I know I'm 2 more than my blue, I'm right here, 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 and there. And tile pattern 4. Wait a minute. One of these things is not like the other. How is one of these things not like the others?
The bottom one, it's lower.
What do you mean it's lower? Because it starts higher.
Yeah, but it decreases when you're not.
Braylon?
The rest of them add more, but it just goes higher, so the rest of them really adds. Like it starts with the lines.
Yeah, there's a mathy word that we want to use here about the difference between their lines. So if I make lines that connect all of these, I'm going to cheat. Sorry, because I can. If I send that to my smartboard, like my smart software, and then I can use it to make lines. Right, my blue line would start here, travel through my blues. But my black, for tile pattern 4, my black points here, what is the difference between these two lines? Or if I compare my black points to my red points, they start at the same place. But then they go two different, like, what's different about these lines? What if you imagine that you were going to ski or sled or ride your bike or whatever? What's the difference between this line and this line? How do you talk about like a hill and how fast you're going to go down it on a sled or a ski? The slope! Here's what I really need you guys to have on here because this is all we really care about. Slope shows your growth. Slope, as we talked about yesterday, is a factor that we start to know as our M. Our M, not our M, but our M. In the equation, y equals m times x plus our b. Now, I am not trying to rush us. So I really do want whatever questions we have from last night's homework, but also realize like it's not due probably till next week, honestly. I don't think I'm going to collect homework from you guys again until next week. I got busy last night and I did not get your homework grades in math. But the people that I talked to yesterday at extensions, I don't think I've gotten anything correct from you guys. Gabe, you turned in chapter 2 homework, and it was, or not Gabe, somebody turned in chapter 2 homework. I'm going to try to hand these out at the end of class. And we really wanted chapter 3. Yeah, it is Gabe. So you collect 3. And I don't know why you turned this in. We can talk later. Because actually, your homework is checked off. So you just turned in something you didn't need to. Yeah, it was okay. I didn't collect chapter 2. I collected the rest of chapter 3. So, from the homework last night, so what issues did we have? And I know they could be from 412 or 413. Any issues from 412, which were problems like 17, 19, and 21? And guys, if you struggled with it, so did your classmates. Like, so please be bold and ask. 19. So we first have to analyze input value x, output value y. So and this is something that I've started to try to like slowly get you guys get this in your head. Y depends on x. So the number of tiles, if we look up on the TV, the number of tiles depends on what figure we're at. Right? The number of tiles I will need depends on the figure. So this, I don't know what's the in and the out, but the output depends on what I put in. So as I go up with my input, my output goes up. As I go down with my input, my output goes down. As I go up, oh crap, I need to fill that in, and then I go to -3, oh crap. So this gets tough, right? If we go to homework help, I just like seeing what they provide for homework help. Let's see what they provide as a hint. So look for pattern between input and output numbers. So 2 compared to 9. Anyone see a pattern, Savannah? times 2 and then add 5. So, if I try this out with the 3 that I have the x and the y for, what's 2 times 2?
4.
Plus 5?
9.
9. 10 times 2? Plus 5.
25.
Seems to work. 6 times 2?
12.
Plus 5?
17.
Huzzah. So what Savannah's saying is it's 2 times the x value, and then you got to add 5. Quinn?
I used the CC3 book, and I've got, and my 4-19 is different than that 4-19.
Then you didn't use the CC3 book.
I did use the CC3.
That's
Was it a
not
green book?
possible.
Yeah.
Are you sure you didn't grab the high school math 2 book by accident? Because I have 3 different books in here. Let me see what type of work it was asking you to do. It is not the correct, like, I think you were looking at the high school math 2 book. These are probabilities. So guys, our homework should always come from review preview sections. If it's in a lesson or something like that, that would be atypical, like not normal. You just somehow had like the wrong book or something, Quinn. You just somehow had the wrong book or something.
Well,
Sorry, bud. So if we go with that, what's 7 times 2? 14 plus 5? 19. And guys, I don't like when homework help goes to the answer, but if you use homework help, it gives you the answer for this one. Because it knows this is pretty new to you. So CPM strategically has homework help either go all the way or not quite all the way based on how long you've been practicing a skill set. So this relationship was kind of hard to see. So they go ahead and they show you how to fill it in. Then explain in words what's done to the input to produce the output. Well, I double the input and then I add 5 with it. Right? Write the rule you described with algebraic symbols, exactly what we just wrote. The y will equal 2x plus 5. Those are algebraic symbols because algebra is the study of math using, well, there's a big definition, but we use variables in algebra. Right? Variables are used for things we don't know.
Can I have a Band-Aid?
Yeah. Oh, I have a bunch actually. You don't need to go anywhere. Other questions from the homework? Here, take it back up, just so you have it on you, in case you like pick the scab again or whatever. Sorry, right, dudes, and you got a haircut now, so now I'm all screwed up.
Yeah.
So, yes.
Okay, so, for, is it 18 or?
17, 19, and 21 were the ones from this.
17. Sorry, the one with just A and B.
Yeah.
So for that one, I just had real. It just took a long time, and I didn't really get that.
So this is gonna be a facepalm moment, which is okay. Those are really good because they help us learn.
Wait, is that true?
This, yeah, but it's zoomed in awkwardly, so it says equals. Sorry, if I zoom out, you'd be able to see that a little bit better. It gets funky when I zoom at different percentages, kind of mess with the images. So if I have 7 minus 3x equals to negative x plus 1, what this tells me is my left side is equal to my right side, kind of like when we looked at like the Batman or the Gotham kind of balance scale in the PBS math video, where if we take away a bad guy or add a good guy or whatever, like it affects both sides. So the only way to keep a scale balanced is if I take something off one side, I got to take the same amount off the other side. Or if I add on to one side, I got to add on to the other side. Here's all we have to do here. And it's okay if we just go over homework problems today mainly and then like get back to whatever amount of lesson we have. If I want to put my x's together, I have 2 options. To get rid of a negative x, we add an x. And then I'd have to do that over here. But I always want to give you the best way, right? So that would work. I can add them to both sides, so I'd have to add an x here too. But if I want my x values to become positive, instead of adding 1x, I could add, oh, come on, give me red.
Red.
I could add 3x to cancel out the minus 3x. If you didn't do this last night, you should do it now. This gives me 7 equal to 2x plus 1. Right? All I did was add 3x to both sides. Any questions on that first step I did? What we're practicing is the same thing like we were doing with fractions, where if I do it to the top, I do it to the bottom. Same thing with equations. If you do it on the left, you got to do it on the right. Otherwise, your balance gets unbalanced. And then it's not equal. I can't be unbalanced. So then, how do I get this plus 1 to come off of this side? And, like, this is the hard thing. I'm not taking a plus 1 over there. I'm taking it off of this side, and then it will impact that side. Right? Minus a 1 over here. And we have to do the exact same thing, so we minus a 1 over there. So I can't minus from that side and add from that. I just got to minus from both. See, and that's the hard thing. Like, that phrasing doesn't quite, like, I'm trying to figure out how to say this better. But it's not that we're taking the plus 1 over there. We're taking it off of this side. But to take it off of this side, I have to take away 1. So I have to take away 1. Right? Questions here. Because this then becomes 6 equal to 2x. If x right now is being doubled, how do I get it back to just a single x? Divide by 2. So we divide by 2. That moment is why I teach. The moment of, I get it.
I found out why I got it wrong.
Were you in the wrong chapter?
No, I wasn't in the wrong chapter.
What was that?
I question marked Cornish to A because I was confused about what I was trying to tell.
Okay, but still your 19 was the wrong 19. Like, you did the wrong homework, I think. Because this is not right for number 19. And this is not right for number 17. You were in the wrong homework somehow. Were you in? Dude, I don't know. I really do not know what happened. Yeah, I don't know what happened. Maybe we just had like a brain goof. We can check the 7th grade book. You might have grabbed the 7th grade book because we're not in chapter 4 yet in the 7th grade class. We're still in chapter 2. We're finishing that up. You might have actually done the 7th grade chapter 4 homework. You know, I mean the CC2 book. I don't know, maybe. So x comes out to be 3. Now, here's the other problem with algebra. We always use x. So x is 3 here in A. But then I move on to B, x is no longer 3. It's a different x. That's like x's cousin. He looks like x, but he's different. Right? Like, that's a thing that people often struggle with. They're like, no, but x is 3. Like, yeah, in A. Then in B, it's going to be something different. Or if it's the same, that's just coincidence. Okay, so x will continue to change. I wish they'd change variables there. We use other variables, z's, f's, k's, whatever. Like, we try to avoid variables that look like numbers. So, like, we don't use I very often because it looks like 1. We don't use L a lot because L is dangerous too. O is horrible. So do I need to do part B or does this make sense now? I'll rephrase. Would you like me to do part B? Yeah, okay, good. So part B, -2 plus 3x equals the opposite of everything in the parentheses. Don't do anything on the left. Just distribute your negative. So this becomes -x plus a -6 or -6 if you want to write it that way. I want to put my x's together. My trick is look for the most negative x. Destroy that guy. Get rid of that guy. So positive, okay, not negative, negative. And if neither of them are negative, you just look for the lowest amount. So this is the furthest down, right? The lowest x. So what do I do to get rid of a negative x? Add x. And I do it on both sides. Don't do multiple things at once. So once I do that, I copy down what my now new equation is. How do I turn a negative 2 into 0? Yep, just add 2. 4x equals negative 4. If I have x quadrupled right now, what do? Divide by 4 and divide by 4. X equals negative 1. Now I'm going to drop some knowledge on you right now that doesn't matter, but I want to plant the seed in your brain. Whenever we multiply or divide with a negative number, we didn't here. We did not. There was a negative on top, but that doesn't matter. If there was a negative on bottom, the symbol in the middle turns around. Now for an equal symbol, that doesn't matter. But when we get to inequalities, you have to be careful when we do multiplication or division. So inequalities, right? Things that use the greater than or the less than or the or equals. Like those we have to be careful when we do multiplication or division. Right now, we can just do it. It's easy. We just make it happen. But when we work with inequalities, which is coming in a few chapters, we got to be careful when we hit that step. Quinn?
I don't understand how you transform 6 into negative 6.
So this is the opposite of everything in here. So the opposite of x became negative x. The opposite of positive 6 became negative 6. That's where both of these negatives came from. Because the negative up front had to be distributed. Does that make sense now? Good, Quinn?
Yeah.
You're upset, but you're good. You're okay, my book. Other homework questions?
26.
Anyone want 21 while we're on this page?
No, I'm
Sure.
busy
Sure.
I mean, don't just say sure. Like, if you had issues or you weren't able to do it, like, give me a yes. I don't like sure. Yes? Kelso, oh my gosh, that 70s show. Kelso wants to put a floating blanket over the family's circular wading pool to keep the heat in and the leaves out. They really just mean like a pool cover, so don't imagine like a quilt. Like a floating blanket is a pool cover. The pool has a diameter of 10 feet. However, what I will help you with is if I went to look up the formula, I go to reference. If I'm on the ebook, otherwise in the book, you just flip to the back. I go to glossary, and I look for circle. Wow, saw it. Oh, hey! Every part of the circle shown to you. Diameter means across it. Diameter literally means meter. The end part of the word means distance, length, whatever. Dia means like across something. Right? So diameter is distance across. When we look for radius, when we look for area, we must use radius. So the issue happens, crap, I should have opened this in a new tab. The issue happens when I am given a diameter. The trap door they've set for you here is if you plug in diameter, you're going to get the wrong answer. How does the radius compare to the diameter? Half it, right? So if you half your diameter, you got your radius. And they don't explicitly tell us that here, but when we get deeper into circles, we will write that out. That diameter is half the radius. Radius is half the diameter, or diameter is twice the radius. You can go either way real quickly. Diameter and radius work well together. Then the trick that I'll start getting in your brain right now, the circumference is the distance around, right? We talked about this morning with our root word study.
Yeah.
Also, if you think of a pie, right, the part on the edge, which like back in the day my grandma would like hand or like literally print every little dimple or ripple or whatever on the crust of the pie. I don't know if your parents make pies from scratch anymore, your grandparents. The crust is made of what? What do you make crust with? Not bread. No, you make it from scratch. All right.
Brown sugar.
I'm going to throw one up to Grandma Edith Wolford. None of you know this, and it's sad because I was raised with pies like every weekend. Dough.
I only ate myself.
Dough. Crust. Check it. This is kind of cool. Crust is pie dough. That's how you can remember. Notice how everybody thought that was inappropriate at the same time. That's a way you can remember the formula for circumference. The crust is the pie dough. That's how you figure out circumference of a circle. So, back in that problem, it was 413, right? Or no, it was 412 that we were still in. Back in that problem, all we're doing is area here. But if they asked you, then he's going to put rope lights around his pool. How much rope lights does he need to go around the pool? That would be circumference, right? So then if they ask you circumference, guys, this is crazy easy. Circumference is pi times 10. So it would be like 31.4, right? Because we know the beginning of pi, and then the blah. Other questions on this one? Otherwise, we're moving to the other one. Mike, is that hand you're stretching?
Wait, what's the C? The circumference?
Yeah, so we didn't need circumference here. The formula that we looked up in the back of the book is area is pi times radius squared. So diameter of 10 feet means the radius would be half of that. So it's 10 across. The radius is just from the center out. So how far would that be? 5. What is 5 times itself? 25. That's how you square a number, right? Multiply by itself. Then you got to multiply that by pi, which you either can use 3.14 or the pi button in your calculator. We don't tell you what to use for pi. We accept multiple answers. At least here. If on a test or whatever I tell you what to use for pi, that's probably because it gets a little messy. And like I just want you to use 3.14, or I want you to use the pi button in the calculator to make your life easier. Other preguntas.
No. What? That means like question.
Preguntas means questions in Spanish.
Everyone's like, what the?
All right, 413. Hold up. Yo, that didn't mean like everybody talked. 413, we had 3 problems in here. We did 25, 26, 28. So I thought those were the best ones. So another tile pattern rule. With a table, you can make a T-chart, just simple T-chart, right? With an algebraic rule, that is your like y equals or whatever. You could even say tiles equals something times like whatever. 26, you use the circle formula again, so you needed to look it up back in the previous homework. That's why I gave you another circle problem to keep like, yeah, this matters, this is important. And then 28, analyzing this analyzing this graph. If you have questions from those, please come see me at AOR Extensions. Your homework is going to ride to tomorrow. Okay, so you don't have to do it tonight. And I do not want questions from your homework today at AOR Extensions. I need to help people with revisions. If you're working ahead, please don't come asking questions. If you're working on like 412, 413, come see me if you have any issues. But if you start working on 414, please like just hold your questions. So I will modify this over here on this board. I didn't know if we were going to get to 4 and 4 today, so I'm going to make this Monday and Tuesday, and tomorrow we'll move on. Thank you very much, guys. I appreciate you bringing questions. This is okay. We can do this every now and then. Have a wonderful day. Thank you. Thank you.